Aloha, I'm Joe Ritter. While I'm waiting for the video, I'll just say thank you to Michael Potter and Chris Stott for inviting me here. My talk is about open source technology, about building starships, about out-of-the-box solutions, and about open design related to open source. My thanks also to Marcel Gieffre from the Homo Spacians Institute who helped with these view graphs. What is the T in TED? Can anybody tell me? Technology. And technology is about tools. The advancement of science is a function of the tools available to us. The tools are a function of the materials that we have. Tools change us, shape us, have made us what we are. The Stone Age lasted 2.5 million years, and it ended around 4,500 to 2000 BC because of tools, because of the advent of metalworking in the Bronze Age. 60 years ago, with the invention of semiconductors, we had a new tool because we had a new material. We're now in another golden age with photonics and metamaterials, designed materials. But the greatest tool that we have is teamwork. And this is part of what I want to talk to you about for open source. A lot of people think of open source as software development and open design as hardware development. I'm not a purist in this, we'll mix them a bit. But open source principles, we are at a university right now which is essentially open source. It's built on teamwork, sharing data, teaching people, sharing designs, and trying to achieve results for common knowledge and development. This has always been part of the scientific community. Open source work is nothing new. Open design is the development of physical products, machines, and systems through the use of publicly shared design information. These goals and open philosophy are identical. The goal is progress towards some beneficial, sustainable technology or initiative. So what are we proposing here today? I'm part of a team where we are proposing an open source development, an open source Starship Alliance to build technologies to send people to other solar systems. I'm also going to talk about an open design legacy tool, OCCAMs, optically controlled and corrected active metamaterials. So a new transformative technology for starships. A metamaterial, a step to facilitate the open source Starship Alliance. What we propose is a legacy project. We want to develop technology for a manned interstellar mission, but at the same time have the spin-offs benefit Earth. Our team is proposing the creation of an awe-inspiring, large-scale venture which aims to send humans to a new Earth. But legacy projects depend on their motivations. There are a lot of motivations. You can think of legacy projects like the pyramids that took centuries. What was the motivation there? For some king to have eternal life. So in that case, it was survival. A few examples, Noah's Ark, if it was real, is also a survival motivation. Reportedly, it took 120 years to build. I'm not religious, I won't get into this. The Great Wall of China, 7th century BC, was politically motivated, and it took over 1,700 years to build. The Cologne Cathedral, 13th century, took 600 years to build. There was a religious motivation. America's voyages of discovery in the 16th century. Think of Columbus, Vespucci, Pizarro. Over 200 years, these were essentially military expeditions, but also to get resources. Great expeditions in the 19th century. Amundsen, Shackleton, Livingston. These happened over more than 100 years, and this was an exploratory motivation. Another legacy project, of course, was the Manhattan Project. Only took 6 years to develop nuclear weapons. And it's cut off at the bottom, but there's quite a legacy around here from going to the moon. I remember when I was 3, watching them land on the moon and going out and trying to build a radio. And in some sense, the teaching I do now and the research I do is a legacy of that initiative. Why bother doing these things? Why talk about crazy things like a starship? Well, growth is not the same as progress. The motivations for an open source starship legacy are survival and exploration. In this view graph, I'm plotting Earth's resources versus time, declining, and GDP growth. You note that they are inversely proportional. Growth is not the same as progress. Our current economic growth is depleting our natural wealth. Current economic growth is based on using up irreplaceable resources. So if we can find new resources, we can maybe still have growth without doing depletion. What are our current motivations for this project? Okay, well, the goal is to send humans to a habitable planet. So the first question is why? And the second question is, are you crazy, Joe? And I realize it's a rather controversial topic, but the reason is threefold: survival, economics, and exploration. Starship technology can push technology we need for Earth, for making energy, for recycling, for life support, for food, for medicine. And also there's survival of redundancy in case we have things like a large comet impact like we had 65 million years ago at the KT boundary. Economics, there are huge riches in space. Helium-3 on the moon, gold, platinum, people talk about mining asteroids. And for me personally, it's about exploration and the ultimate in what you can do to achieve the human spirit and to achieve knowledge. And I'm interested in knowledge. The world should commit to a project like this that is open source, even if it is long term. Here's an example of some of the economics. Currently, global tourism market is over $2 trillion. There are a number of people actually in this building who are working on space tourism right now. The estimates are maybe by 2030, that would be a $100 billion industry. Space energy, right now on Earth, it's a $6 trillion a year market. Space energy, people talk about upwards of $1 trillion. I'm not sure if I agree with that because launch costs are too high to do things like space solar power right now. Space mining, there have been recent things in the news about space mining, so I won't even touch that, but the estimates are hundreds of billions of dollars in resources. It is clear that we will find a habitable extrasolar planet, a new Earth, soon. The estimates are that there are maybe as many as 10 billion Earth-like planets in our galaxy alone, and of course, billions of galaxies. The Earth sum global GDP is something like $70 trillion right now, a year. Now consider, with all of these planets together, if you could tap any of this, something a billion times that, 10 to the 9th, or even 10 to the 10th times that. Later we're going to hear a talk by Peter Diamandis about abundance. I don't even understand numbers like this, with 70 trillion and 10 billion times that. I do understand the idea of having 10 billion times the amount of knowledge. In order to develop something like this, strategic investments need to be pursued in the space industry to make a starship. And I'm just going to look at a few. But the idea in this graph is you have a central organization that is open source, and you work towards going to this new Earth, yet the spin-offs go to making Earth sustainable. And that is the economic model. That's the only way that people will get behind things. It's great to have this vision to go somewhere else, but realistically, money won't be put into it unless there's benefit here on Earth. We look at the possibility of space tourism, education, biosuits, space biology, manned asteroid outposts, lunar bases, orbital labs, on and on. Each one of these things are an industry that can be developed. There are an abundance of opportunities for every single industry on Earth. This last chart that I put up only shows some of the basic industries which, once developed, can provide elements to build a starship. So great, there's this vision, so what? It's one thing to have a vision like this, and it's another thing to proceed with it. And lots of people talk. So in the spirit of collaborative creativity and open design, here I'm going to share an open design project with you, which I believe can help with all of these things. This is a combined imaging, power generation, and distribution, propulsion, and communication subsystem for a starship that one can build using optically controlled and corrected active metamaterial structures. Let me go back. You all probably recognize this tool. This is the Hubble Space Telescope, which revolutionized our understanding of science. It only has an 8-foot wide mirror. It's fairly small. People have envisioned much larger systems for space interferometry, for finding life with multiple phased array telescopes. a terrestrial planet imaging array, and all of those things have been scrapped and are not happening. Right now, what we have is the James Webb Space Telescope, which maybe will get launched at the end of this decade and maybe will cost $9 billion, or maybe twice that. When I originally worked on it at NASA, it was $500 million, including launch. And so that gives you some idea of the problems in the state of this technology. So you need bigger telescopes for knowledge, but you can also build starships with them, and I'm going to show you how. How do you make bigger telescopes, yet make it cheap? A key thing in open source technology is accessibility. Michael's black boxes, the iPhones in space, things that are very inexpensive and accessible are what can bring people in. Well, people talk about making large telescopes out of many segments. That's a brute force approach. You can make telescopes where you make thin optics and you push on them. That's actuation. That's a much more elegant approach. I'm going to go off for a second from open source starships to space telescopes and the idea in how you design optics for this. You require an ultra lightweight mirror, and typically the shape of a mirror, if it's a curved mirror for a telescope, has to be precise to a millionth of an inch. I don't personally understand numbers like that, but it's about 1,000th of the diameter of one of your hairs. So you have to polish a mirror that is incredibly precise. This is very expensive, and they have to be very thick so they don't slump under their own weight when you're on Earth. Mirror actuation is a way to make thinner mirrors. You can have a shape and push on it on back, and so you can make thin mirrors and correct the shape when they sag. You can make a much thinner mirror if you have more dense actuators. So when you're designing a space telescope, you look at the design trade space of the current technology and say, well, what is my actuation technology? How thin can I make my telescope? How light can I make it? And therefore, how inexpensive can I make it? The key thing here, the point I'm going to make, is to try to look at the extremum of the design trade space, not only for this, but for everything. So the extremum here is to make something that is infinitely thin with an infinite number of actuators. Well, I don't know how to do that, but I do know how to make something that is as thin as saran wrap, where every single molecule is an actuator. So instead of maybe 1,000, you have 10 to the 23rd actuators. Here's a view graph from some of our quantum ab initio calculations of a simple molecule, diisobenzene. And what happens is when you hit it with light, and this has been known for 50 or 60 years, it will break its bond and extend. And so in this view graph, you can see here's one length, here's another, and you can control its shape with light. And it made me think, can you actually make something macroscopic where you can control the shape with light? Everything in the universe is a transducer. Everything converts one form of energy to another. Those lights overhead in my eyes convert electrical potential energy to heat and to photons radiating towards me. What I'm talking about here is a photonic muscle, a new transducer that converts light to motion. And so we've done this. This is the best material we have so far. This has been described by a few people to me as magic. What I'm doing is controlling the shape of this thin membrane up here with a polarized beam of light. I'm hoping the video will repeat. I hope all of you got to see it. It's not repeating. Okay. The idea is to make a large membrane out of this. Okay. Make a large membrane and actuate the system, scan a laser beam over it. I've built such a system under funding from the NASA Innovative Advanced Concept System. And that's not the video I thought we had, but I'm showing a laser beam scanning over a small mirror, changing the shape. Oh, here's another video. There we go. And so this shows how you can make something as thin as saran wrap where you can keep the shape perfect to a millionth of an inch. So I'm going to wrap this up in a second here. We're ready to accelerate development on this now. Shown here, that person is not very tall, but they're not a dwarf. You can see a very large membrane there. And on the left is an assembly to make a telescope mirror the same size as the James Webb Space Telescope mirror, except this would weigh only 6 kilograms. What can you do with this? Well, once you have a large dish, you can do telescopy for a starship, you can generate power, you can do life support and thermal regulation, you can do propulsion, you can make it a solar sail, you can add an annular support, you can do solar thermal propulsion, you can make a photon microwave drive, you can do multi-mode propulsion schemes, shown above, where first it's a solar sail, You can generate power by collecting light. You can transmit power with microwaves. You can distribute power to free flyers that are going into a star system. You can make mission concepts like this where you change from a solar sail to solar thermal propulsion to a photon drive. There are many other uses, a solar furnace, a mass spectrometer recycling facility, so that every single molecule on a starship could be reused. This is the kind of technology that will help us make a sustainable Earth. That is the vision with the help from the next generation. As I wrap this up, I just want to put up a picture done by a 16-year-old artist on Maui, because this will take a while. This is a legacy project, and I've extended just one idea from one person here. With open source, we can actually do much more than build a telescope, even a 100-meter telescope. We can together build a starship. What are we proposing again? An open source Starship Alliance and an open design legacy tool. We want to build starships, we want to build 100-meter space telescopes. This is the beach I would like to see you on.